Welcome to my presentation on wind power generation system. I will elaborate wind turbines, their types and parts. So let us move on to the definition of wind power. Wind power is a form of energy conversion in which turbines convert the kinetic energy of wind into mechanical or electrical energy that can be used for power. Wind energy is electrical energy obtained from harnessing the wind with windmills or wind turbine. Wind energy is a form of wind power, which is the use of wind to generate useful work. Let me elaborate further on what is wind turbine. A wind turbine is a device that converts the kinetic energy of wind into electrical energy. A wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. The main components of a wind turbine are the foundation or base, the tower, the rotor and hub, the nacelle, the generator, the gearbox, the brake, the yaw drive, the pitch control, the controller. Here are the main steps of how a wind turbine works. Wind, moving air that contains kinetic energy, blows toward the turbine's rotor blades. The rotors spin around, capturing some of the kinetic energy from the wind, and turning the central drive shaft that supports them. The drive shaft connects to a gearbox, which increases the speed of rotation by a factor of 100. That spins a generator that produces electricity. The electricity goes through a transformer, which increases the voltage so it can be efficiently transmitted over power lines. There are different types of wind turbines based on their design, size, and orientation. Horizontal axis wind turbines. Vertical axis wind turbines. Darier's wind turbine. Gyromill wind turbine. Savonius wind turbine. Horizontal axis wind turbines are a type of wind turbine in which the rotor blades are mounted on a horizontal axis perpendicular to the direction of the wind. The main rotor shaft and electrical generator are at the top of a tower and may be pointed into or out of the wind. A vertical axis wind turbine is a type of wind turbine where the main rotor shaft is set transverse to the wind while the main components are located at the base of the turbine. This arrangement allows the generator and gearbox to be located close to the ground, facilitating service and repair. The Darier's wind turbine is a type of vertical axis wind turbine used to generate electricity from wind energy. The turbine consists of a number of curved aerofoil blades mounted on a rotating shaft or framework. The curvature of the blades allows the blade to be stressed only in tension at high rotating speeds. The gyromill is a vertical axis windmill with a series of articulated vertical blades whose angles are controlled to maintain a constant RPM when wind speed is sufficient. A microprocessor is used to process information on wind speed, wind direction, and RPM and establish blade position. Savonius wind turbines are a type of vertical axis wind turbine, VAWT, used for converting the force of the wind into torque on a rotating shaft. The turbine consists of a number of aerofoils, usually but not always vertically mounted on a rotating shaft or framework, either ground-stationed or tethered in airborne systems. Wind power has many advantages as a renewable and clean energy source. Free fuel. Clean and renewable energy source. Independent energy resource. Range of sizes. Local and domestic energy resource. Cost-effective energy production. Price stability. Grid integration benefits. Technical issues in connecting to grid. Wind power is connected to the grid by using transmission lines that carry electricity from wind farms to substations and distribution networks. However, connecting wind power to the grid poses some technical and economic issues, such as generation uncertainty. Wind power is variable and intermittent, meaning it depends on the availability and speed of wind, which are hard to predict and control. Wind power can cause power quality issues on the grid, such as voltage variations, frequency deviations, harmonics, flicker, and reactive power imbalances. Wind power can affect the angular and voltage stability of the grid, which are measures of how well the grid can withstand disturbances and faults without losing synchronism or collapsing. Wind power can affect the reactive power balance of the grid, which is the amount of power needed to maintain the voltage levels and transfer active power. Wind power can affect the fault ride-through capability of the grid, which is the ability of generators to remain connected and operate during and after a fault on the grid. That's all for today's video on wind power generation system and wind turbines. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topics you want me to cover. If you want to see more videos like this, please subscribe to my channel and click the bell icon to get notified whenever I upload a new video. Never forget to share and comment. Thank you for watching.